Hey guys, I'm in Stormworks again tonight, and tonight I got a lot of topics I want to cover, but I'm sort of having trouble getting my mind organized, and a lot of them are sort of related. I mean, I have here a collection of project trains or trains that are giving me some level of difficulty as I'm trying to maintain them as part of my collection. I don't I don't really intend to republish them. I mean, like for example, this train right here, it's beautiful, and I think I showed it once before in a previous video, but on here, let's take a closer look. Like for example, it has these truck things, and these really fancy trucks, and I'd been driving it over North Sawyer Overhaul, which of course that mod puts in pretty twisty tracks, and it basically shows you all the problems in your setup. And so not only do I have my own wheel assembly under there, which I've had for ages, I've had to weld the outer shell to that assembly so the entire thing rotates. And actually in the back here I use a slider. I'm using here, and this one slides back and forth where this one's locked to the chassis. And okay, now there's a cut here, and it's, well, I mean, it has to slide back and forth. So what am I supposed to do? But anyway, so I drive this thing, and it gets hung up on the ground. Like when I was trying to build this train here, it just got hung up on the ground, and I'm like, what the heck? Now, I'd gone under here, and I looked at it, and there's like that's a piece, that's a piece. I mean, of course, there's the chassis. So what I did was I welded the left and the right together. So, okay, cut down the number of pieces. Basically, you did the same back here. Like this is a cross beam. Left and right are welded together. Left and right are welded together. But and you see here, I mean, that pivot's not holding; it's dropping down. So this frame here is lower than it should be, and much lower here too because that pivot's junk. So I don't know what I'm gonna do with this train. I mean, I want to preserve the author's original intent. The original designer even put these work lights under here, and I think it's a very innovative feature. I mean, there's a switch for it over here, and so this is a really well designed piece here, and if the pivots just held and at their correct length, a whole in the laundry list of problems in this game would not happen. But I mean, we go back here, and you can see, I mean, on this side it's kind of holding on, and right here it's supposed to be completely straight, and it's dropped down. So what am I supposed to do? I mean, I mean, it's a beautiful train, and I would like to use it more and keep it in my collection. But it's, what the heck? This is one of my own creations. This is Mo, and it has my own electronics package. And people tell me that my electronics package is too large and too complex to fit on a train, and I'm looking at this thing, and I'm like, really? Really? It's too big to fit on a train? I mean, it's okay. There's one of the controllers there. I mean, I guess I could have hidden it in that panel there, but I decided it kind of made sense for it to be right here, and then it would drive the control stand right there. So I don't get it. I mean, well, let's stay on that subject. Let's talk about control systems, like for. And once you have a locomotive and it pulls a train, I mean, a train is not just a collection of carriages and connected together. This is a joined consist where it's just basically I'm sharing the bogie between these two cars here. But I mean, I do eventually come to a trailing bogie and a trailing connector. And I guess I could cut it right here and then use this connector. But again, but the issue here is that you're not just creating a set of cars that are bolted together, you're creating a train with those cars. And that means that once they're connected, then signals flow from one car to another. Like right here, I have a brake, and now right now it's at 8.4%, and so I can go here and then find that's where my 8.4. I'm going to push it up to 1, fully lock the brake, and as you can see, the signal is passing down the length of the train, and then any connected cars stop. So that's a good feature. So basically you want a train control system that allows you to and operate the equipment on the entire train. So you basically assemble your cars in any way you need, and they all work together to do what you need it to do. So, in order for that to work, you need standards, you need a system and a set of electronics which implement those standards to create a train. Now, there was a group called the Stormworks Rail Committee. They created this unbelievably Byzantine system that I guess it's kind of like a real life system, but it just was just an unbelievable. I mean, let's see if I can load up one of their controllers to instead of just bellowing expletives or superlatives. Let's just look at this. Let's load. Let's see if I can load it down to workshop. Let's see. Lighting system. Display. Yeah, alright, there's their main controller. Let's take a look at this. I mean, look at this. Look at the number of connections on this thing. I mean, they just... I guess they got really proud of this, and then they started sniffing their own flatulence, and they liked the smell, and then they... and things just... things just went crazy, and this is... So, this standard, I mean, nobody can figure this out, much less use it. I mean, you literally have, hundreds and hundreds of connections here. And it's just, whoa. Alright, so that's the end of SRC. Now, the next... The current standard, the current popular standard is on Engineers of Stormworks. Let's see, let's take a... How did I load that? So, I was on the... Notice I'm on the workshop page, so this is a fresh load from workshop. I have not done anything to it. Now, the problem with criticizing this is that whenever you criticize it, the author says, "Oh no, that was last week's work. I've gotten so much better since last week," and I'm sorry. This is his latest published work, at the time of this time of recording this, and I'm not going to criticize one of his older pieces. I'm going to take his latest work, and I'm going to be as fair as possible. Now, what we have here is a pretty good exterior. I mean, it's got And the you got to remember about trains. There are two types of trains in this game. There are game trains, which are trains intended to work very well in the game and be a lot of fun to use, which is the type that I prefer. And there are replica trains where people who are probably into model railroading or stuff like, or historical railroading, or just railroad fans in general, and they will produce a very, very detailed replica of a historical train. And the second train that I'm kind of aiming at, the blue one that I'm aiming at, is another one of those replica trains. That one is actually made by a guy who goes by the handle Geronimo, and he is an actual real-life engineer, and he basically made a replica of a train he actually used in real life, and no matter what technical flaws I might find with it, and I cannot criticize the guy. I mean, that is a real train, and there's nothing to criticize here. Like you look at this, okay, it's well painted, it's got details. I mean, it's kind of tricky to find the door there because everything's red and you have to know where it is, basically, and that's a bit annoying. And then you go in here, and it's kind of, you see, the engineers of Stormworks, they like to use XML blocks, and here, because they used XML, it's Z buffering, and it's so. And the XML editing your blocks does not come for free, and it creates problems sometimes. And I'm sorry, it's just. So once again, the cab is highly detailed, highly realistic, and they've probably used a number of real life sources to find out and put the buttons, make the buttons as close to realistic as possible. He's got this selector thing, and you have to say, okay, this lever needs to be a throttle, so you have to put this in the position to make that lever a throttle, and then the train kind of works, which is, I don't know what to say about that. But okay, I mean, it's a realistic train. I mean, let's compare it to Geronimo's train, or my. I've been trying to maintain Geronimo's train, and it's. I mean, it's basically the same as that red train. I mean, the cabin has basically the same feel, and basically the same thing is going on. So you have pretty much the same. I mean, it's at first blush, it's basically the same kind of things are going on here. And this was made about 3 years ago, so the game has moved on since this was created. So some things might be done a little differently right now, but as you can see, an enormous amount of talent has gone in here. I mean, to make it move, you have to take off the handbrake and do a bunch of stuff. He actually, Geronimo himself made a video about this train, which I should look up a link for. And then you can sort of bounce it off of the workshop page. That's where I found the video for this train. But, I mean, you refer to the Geronimo's original video for the exact details. But my point is that basically these two trains are of the same family, and that they try to replicate a historical train. Now, the point I'm trying to make about engineers of Stormworks, once again, this is directly from Workshop, absolutely untouched by me. So let's grab it and take a look at it. Now, engineers of Stormworks are pushing what's called Wobby Sim. I want to talk about later. That's again, a good idea, but I don't know what to do with. Well, I'll talk about that when I get to it. Now, under here somewhere, if I can find it, is a controller. Let's see. Where'd this sucker go? Well, it'll be. You could find it by the data port, the data link view. So I select that. Yeah, this is a modification of the what they call it ESS version 2. So this is ESS 2 with apparently some modifications for this specific build. But this is the system that they're promoting as the go-to standard for building trains in this game. And so let's see what's here. And we get this. Okay, this is, I mean, from a complexity standpoint, it's not outrageous. Let's take a look at this. I mean, okay, we got a NOT gate, AND gate. Oh, wait a minute, we got a lot of NOT gates. Let's take a look at the NOT gates. Start with one there. Okay, another one there. Another one there. Wait a minute, these two gates have the same input, so therefore they have the same output, so therefore they're redundant. So we do that and delete that. And okay, well, let's take a look at another one. Oops, once again, same input, so therefore it's redundant. So therefore we do that and get rid of that. So you could spend hours and hours and hours doing that. Let's load up an ESS. I think this is another ESS 2, and so this is what I've been working on this for like 5 or 6 hours, and this is kind of what I ended up with. I mean, again, trying to penetrate the design, trying to figure out what. I mean, there are a lot of different things. Like, for example, you have this is an OR group, so you got a group of OR gates. So you can swap this line with that line, or that line with that line, and it's the same. I mean, you could also say, okay, well, here's an AND group, and you can swap that with that, and that with that. Then you can say, okay, well, this this AND gate is exactly the same as. Well, let's see if there's the same. Well, that's a different AND gate, so that's good. So if you find the two gates that are the same, you combine them and simplify it that way. Sometimes, like it would have like an AND there and an AND there, both going into the OR, and then with the same input like that. So what you do is you move the OR over here and take out one of the AND gates, and that's again, it simplifies it by one AND gate. So there's a lot of that going on in here. But I mean, it's still a mess, and it still doesn't make too terribly much sense. I mean, let's see, you got headlights here, engine run. Let's see, that's a purple channel. Prime mover and electric throttle. So, what do all trains have this architecture that they have a prime mover and an electric throttle? Well, let's think about this. We got diesel, electric, and trains, like the little red one that I had out there. Okay, I made a video about diesel electric drive, diesel electric distilled. The same architecture where you get rid of this, and can drive your train by controlling the prime mover, which is realistic, and I think a lot of trains do it that way. Or you could then discard that, put this on automatic controls, and control your train by that. And now my system has a little bit of trouble with that, because if you have several different prime movers, and they're basically fighting each other over the state of charge in the train, and it doesn't completely work that way, but at least I'm aware that there's an issue there. So basically, the evaluation of ESS comes down to whether some sense can be made out of these two inputs. Now, the evaluation can be done strictly on the input side of those inputs, and let's see what the train, how each of these inputs are derived. We don't care about the output side, because that'll be specific to the hardware of the train. But we do care about is whether having two different channels in this design makes any sense, and we should be able to figure that out by looking at the input side to this circuit here. So we know that this has pretty garbage controls down here that would need a lot of help before going anywhere. But is it even worth the time here? So let's take a look at this. So we're going to go to data view, and we're going to find our inputs. Now we get the electric throttle in. Where is that coming from? Now that's coming from a multiply AB. So where's B? B comes from the reverser output. Let's see what even this is. Alright, so the reverser comes in. Let's see, this is the... Well, you never have a zero there. That's... You just delete... Well, the trick with deleting zeros is, like, sometimes it'll say 0.00, but then you click on it and it says, like, 0.001 in the actual data, and you can't delete those. But if it says 0.00 and you open it and it's 0, then delete it. Just do it. Don't think about it. Don't argue with me. Just delete it. All right. Now, if the throttle lever is greater than 0, then not. So... Yeah, I think this train has a really funky reverser on it, and it's a real funky piece of work. But the end result is a looks like it's a tri-state, and that if the dynamic brakes are on, then the reverser is forced to 0. Otherwise, it's controlled by an up-down counter, which can take values -1, 0, and 1. I mean, it doesn't look too terribly bad, but it's weird. So we have a... So what were we doing? Let's see. Go back into data view. Find out where we were. All right, we were at this multiply here, and the multiply comes from this throttle right here. So that's how they're controlling the throttle for the... So the electric motor, it's basically driving like a diesel battery electric. So it's it's basically passing the throttle signal straight to the multiply against the reverser to the command output box, the ESS system. So therefore, that circuit is a looking at, if that was the only thing I knew about this train, then it is a diesel battery electric, because that's how diesel battery electrics operate. But we still have the other branch. Let's find that here. So we got a prime mover throttle in, and then the other one is dynamic in. I think that's actually this, and they have this. They like to try to emulate dynamic braking. Like if you take an electric motor and you put a 10 ohm resistor between the terminals of the motor. Never short them out, and just always using a resistor for this. Like if you have a 10 ohm power resistor, real beefy resistor, and you put it across the terminals of the motor will behave like a generator, and the resistor will basically short out. Well, and not almost short out that generator. You do not want to actually short out that generator. You just very as close as you dare to shorting it out, and that will actually behave as a brake, or what they call a dynamic brake, and you can slow the train down without causing any wear to the wheels or the brake pads or anything like that. So it's a good way to slow down your train. It's just that it doesn't make sense in games. So what they usually do is they go, I don't know why they have two motors down in this truck, but they would take a generator and a clutch, and when they turn on the so-called dynamic brakes, they put that signal into a clutch, which drives the generator, which sort of a regenerative braking system. Does it make sense in game? No, because inertia is not really modeled in the game, and the train does not have enough inertia to warrant any effort to recover the momentum, and it'll basically stop on its own within a couple 100 feet anyway, no matter what you do. So therefore, you can almost live without brakes even. What the hell is this? There, better. Anyway, so what they're doing with the electric throttle, well, let's see, we covered that. Let's start. The prime mover throttle in comes from the dynamic brake controller, and let's just take a look at that. Let's trace the signal all the way through explained the dynamic clutch and just now. Yeah. I'm OCD. This is ugly and I'm OCD. Okay, there we go. Yeah, this thing's really messing with my OCD. All right, well, let's see. Let's just digress and do a little trick here. Let's. All right, so we have an OR gate, And this can be, this is, let's get this org. Yeah, for some reason this menu loads up kind of funky mode. Let's see. So this go to there, and go straight to there. All right, this is now optimized out. So we have an org. I'm gonna get 2 of those. Okay. So we've combined the NOT gate with an OR gate, and we have another OR gate up here, which is taking a NOT. So let's think about this. So if the input right here is cold, and the input on the, let's see, yeah, if the input here is cold, and we had another NOT gate, and let's say we had a NOT gate here, and that was also cold, then both of these would be hot, and so that would be, since that's an OR and it's receiving hot, then it would be hot. Now, how do we make it cold? Now, if we make this hot and that hot, this would be cold, that would be cold, and that would be cold. So the thing so the state we don't like, or the state that makes us cold, is this being off, this being on, and that being on. So this and that makes us cold, which becomes a NAND. So that goes there, and we're flipping this from positive to negative, so we'll use our NOT there, and take the output of our NAND like that, and that goes away, that goes away, that goes away, and that goes away. And my OCD is now satisfied. Anyway. Yeah. But let's get back to where we were. We prime mover throttle in, and it's gated off of whether we have this engine roan signal coming in. Okay, so basically this is a pass-through. We're simply gating it based on whether our dynamic brakes are engaged. Another trick is that when your stuff is well organized, when your stuff is approaching well optimized, it'll actually lock together like that. And so when everything locks together, you know you're pretty close to a well optimized system. And when it doesn't, then you know you got problems. So it's just the way it works out. Let's see. So yeah, this just kind of goes in like that. Well, there's no point spending any more time in here, so we'll just. All right, so our prime mover is basically a pass-through from here. Now, where does that come from? All right, and it comes from there. And we trace that up, and we find our throttle lever. So, on this, one of the most recent examples of an ESS train, ESS version 2 train, we're basically giving the same signal on 2 lines. So this line being the prime mover, it actually has a range of 0 to 1, where the electric is modulated by a reverse signal that's a -1 to +1. But it's basically so basically one is the raw throttle value and the other is the throttle mixed with the reverse value. And for some reason, I'm supposed to think that this is a good design and that I should adopt this design and put it on my trains. And I'm like, no, this does not belong on my trains. Sorry, it's no good. It's bad. It's serious. I mean, I'm going to show this video to the EOS group, and they might ban me from their group for throwing this much shade at them. But I mean, I'm sorry, I can't. Let's see. Yeah, there it is. All right, let's look at my. I think I slipped the original donk controller on here. This is the oldest system in the game. It was actually shipped with the game as part of the as part of. It was in there actually was when the game was in beta. There was actually a train that had this system on it, and this is a cleaned up and OCD compliant version of that original system, the donk tram control system, and it's got some nice things. Like, it uses this trick to invert numbers. Like, it doesn't do any processing. It's purely a switch box. So when for example, we take all right. How does this do throttle? All right, this is the throttle right here. All right, this is the throttle, and we take the throttle and it goes out there. I mean, like if now, yeah, all right. This is this is the throttle input. This is the throttle from the. So the throttle just simply goes in here, hits a couple of switch boxes there, and leaves the other side. So that's all it does. Now, the throttle also, all right, our throttle signal is sent to the rear connector straight, and it is flipped, inverted to the front connector. On the other side, when it receives a throttle signal from the rear connector, it inverts it, and when it receives the throttle connector, the signal from the front connector, it does not invert it. What this means is that if you have trains back to front, you can it works. If they're front to front, it works. If they're back to back, it works. So it always works. Beautiful system. Now the problem is that it's just a stupid switch box, and it doesn't think, it doesn't really help you drive your train. So let's look at my system. And at first you think, oh my God, this is like a Stormworks and SRC, and it's all in haughty. I'm sorry. Again, this is as OCD compliant as I could make it, and it's just there's a lot going on here. Let's take a look at one of our signals. Let's find a signal. I think I'm still using the let's find one. It's got a lot of stuff. Let's see, the throttle would be down in the green. No, it's not. Yeah, I think that's the throttle. That's the master throttle right there. So where does it come from? Where does it come from? So we have three basic sources of data. We have the rear connector once again, the front connector, and the that's an auxiliary input. And we have the control stand, which I have to find that. Yeah, this is the train operator. So we have the train operator, the rear controller, and the front controller. We have 4 different modes of operation. Therefore, we have on the train operating in standalone mode, with that's basically with most of the system disabled. We have the train operating with this locomotive controlling the entire train. We have this locomotive being driven by the locomotive in front of it, and we have this locomotive being controlled by a locomotive behind it. We have a tooltip here so it basically diagnoses what condition it is in, and it reports a tooltip so that you can say, okay, I'm the master, and I'm being, or I'm not the master, but basically it's a diagnosis of which state the locomotive is in and how it's being controlled. The throttle does not go directly out. It goes to a separate module which actually controls the final drive. So basically this system is more like an SRC. It's not a single system. It says it has a separate module for the user. It has a separate module for driving the controller on the train. This system does not know what type of locomotive it is on. It knows that there's another system which does know what type of locomotive it's on, and it sends commands to that because it knows things that this system does not know. So we can take another thing that ESS was doing was lighting, and that's basically, so I put that in this controller here. This is the supplemental light controller, which has all of the AND gates and stuff. And so yeah, it's so I took all of those AND gates and stuff and moved it completely out into a completely different system. You see, this is pretty well optimized. You see what one of the checks you do, if any wire crosses that line or that line, then it's an issue. Like here, you can sort of put it like that. Okay, you got a line there, backward flowing line. That's you really want to avoid that. But then I had, but so yeah, it's not great, but it's. I mean, that's clean. The master controller again. Well, the master controller is doing what it thinks it needs to do. That's why it's this complex. Let's take another line. This is the control to the brake. Now the brake, there's an independent brake. That's the brake that affects just this locomotive, and it has also has a automatic decoupler system that'll actually decouple cars, but that's a little bit advanced. And I started taking that off of my recent stuff. I mean, it's still a part of the controller, but so it has a train brake and an independent brake. The independent brake is saying, well, let's see which is bigger. All right, if either the train brake or the independent brake is on, then apply that signal to the brake and use the max function. Now the train brake, which is this system here, says, okay, well, let's see if I have a brake command from the front connector, the rear connector, or the control stand controlling the train brake, and then that's my train brake signal for this locomotive. Now for the front connector, the signal is, well, let's see, the front connector is set up from the rear connector and the control stand. The rear connector is set up from the front connector and the control stand. So it's basically going to. So what I'm saying here is that I went down the list of signals involved in operating the train, and each signal is processed and routed, and exactly in the best possible way for that specific signal, based on what it is, what it needs to do, and the end effect of that is, well, let's just take a look at it in action, and let's go back to the little red train over here. Somebody else visited. I'm on a server, which I shouldn't be, and apparently it's a very quiet night and nobody's joining, which means I get to make this video. So let's take a look at this. So once again, earlier I went to the car and I set the brake, so I can take the brake off here, and I can go over to the car and apply the brake. And now I've applied the brake from the car, and because the train control system takes the signals from anywhere in the train, see, my brakes are now fully applied because I've set them, and I've applied the train brake from the car. I can release the brakes, and now the brakes are released. So the locomotive and the consist here are cooperating and helping control the brakes. Now I want to take that off there. All right, it's pretty good. Now let's take a look at the good old Mad Dog. I showed the Mad Dog in the previous video. It was involved she was driving it over bad track. There is no mechanical problem with the Mad Dog. I've driven it and hundreds of kilometers over basically the entire network. So there is nothing wrong with Crimwin's Mad Dog. Now the Stormworks, the SRC people, anybody who's still advocating SRC, is going to come after me and say, "Oh, your control system is lame. It controls the throttle where you're supposed to control the speed." Look, a locomotive in a train with other locomotives cannot control its own speed. It can make tractive effort, which may accelerate the train, or it may apply its brakes, but it does not have control over its own speed. Its speed is controlled by the entirety of the train. Now, if you want to control the speed, you can control it prior to entering the control system. Now, since subsequent to the last video, I've added a lot more controls to the stand here. Let's spawn this and take a look at it here. So this basically fires up the generator. I had a video called Stormworks Railroading Masterclass, where I basically covered everything that I know about generators. That was several years ago, and this is basically that same a very basic version of that same generator. Now, from here, I have to. One of the things my train control system does, it actually requires you to enable the traction motors. So you have to turn on the traction, and now you can set it to speed control, and I've set it to 15.7 km, and that's about, well, apparently between 9 and 10 mph, and it's holding it. All right. And it works just fine, even though it's using my system. It's. I have to explain now that's actually working. Now, Crimwin's system, it was a speed control system, like SRC, but not as stupid. And this is actually a Crimwin's controller. And again, I've OCD'd it. And after OCDing it, it has a system where it outputs a throttle signal and a brake signal. Okay, great. All right. Well, the problem with this system is that if you attach a second locomotive to it, that second locomotive will try to move this one, and this one is speed controlled, and if it's set to 0, it will apply the brake and not move. And that's a problem, so you cannot use this in a train. So I can take this throttle signal, and that goes directly into my controller, and it's happy. The brake, however, is a little trickier, and what I had to do there is I took the where did it go? Yeah, it's... Alright, that's the throttle, and then that should be the brake. So I took the brake, and where did I put it? And then I gated it to... let's see, where did... Yeah, that's the problem with these... That's the throttle. I also have a traction control system on here. I covered the traction control system in the Stormworks Railroading Master class, and I've not updated it since then. And so that's that. It still works. Where did it go? All right. So I have this switch box here. So what this does is it receives a command from the control stand. So if the master, if this on the train, if this locomotive is eligible to be the master, it is, and this is in the on state, and we receive the brake signal, which is then sent to the train master controller, which I have wedged under here. That's the train master controller. But if this is this locomotive is in slave mode, it disables the brakes, and therefore it can be pulled around by another locomotive, and it will respond to brake. And so if the other locomotive orders brakes and the train brakes, this will brake, and that's good. So, and it's basically working. Except the only flaw to that system is that when you're in slave mode, you can't stop the train from this thing. It'll be completely locked out, which is, well, that's just the way it is. Like my other trains do not. There's no concept of master slave when it comes to braking. You get to any brake lever on one of my trains and stop it. And for game purposes, that's great. In real life, I think they actually have the locks which lock out the brake stands you don't want to use, just so you don't have to hunt down you don't have to go to every locomotive and everything to release the brakes. So Crimwin's controller basically works. Let's spawn this again. All right, we'll do a test of this. Let's just test this out. We're gonna spawn this. And let's see. Turn this on. Turn on traction. Pull it out again. Alright, stop it. Yeah, it's a one lever drive system. It's kind of... I mean, from an ergonomic standpoint, it makes sense in this game because you can't operate two levers at once, and a lever is slow to operate, so having a single lever actually makes it a lot quicker to control. Let's see, yeah, apologies for how I saved it on my collection here. This is basically unchanged since the previous version, the previous video that featured it, which I think it was what usually happens in Stormworks when you railroad. So I'm going to just simply hitch this up without doing anything whatsoever. I'm going to just set reverse, go in, hitch it up, pull it out, and that's it. And I'll go a little faster. Just give it a little speed. Okay. We have not boarded the red train. We have not pressed any buttons. Not done anything whatsoever. So let's pull up. Let's see. Pull up the brick. This is the test weight that engineers of Stormworks uses to. It's just an absurdly heavy weight, which is absurdly difficult to pull, and we use that to test locomotives. So let's do a test then. Now, reverse this. Alright, let's hope it connected. It did connect, and it's very, as you can see, it's kind of yo-yoing. All right, let's see what happens when we try to pull this. Let's give it and command it to a high rate. Let's see. So I can see it's doing quite well, actually. I mean, the Mad Dog is a monster of a train. Notice the smokestacks of the second. All right, we're at our limit here. We're at our each of these bogies is rated at like 100 units of force, and so we're at our limit of what this train can do, which is about 25 miles an hour. And I guess we're going to have to do our startup procedure for the second locomotive. And I will now demonstrate that startup procedure thusly. And the second locomotive is now pulling. And we're picking up speed, 20 and 30, 33, 34... So we're still trying to pull it a little faster than it can go, but we now have two locomotives working on the load there, and it's quite good. Now, the Mad Dog is a diesel battery electric, so I'm controlling the electric motors on this one, and the reason it does that is because it has that sky crane, which also uses electric. Yeah, geez, see, everyone's slipping like a son of a bitch. I'm gonna have to pull that back. Alright, let's see. Yeah, the red train is diesel electric. So my control system is controlling electric motors through a traction control system on this yellow train, while simultaneously controlling a diesel engine which produces power, which by the amount of power it produces throttles the electric motor on that train. And both trains are doing two very different things at the same time, yet working together and pulling the brick at a pretty respectable rate of speed up an absurdly steep hill right now. Let's take a look at our hill. Yeah, we're definitely still going up. Well, we're leveling out now, but yeah, that's. But I think I've made my point about my train control system, that it is a working system that's basically, it's got a lot more engineering in it than is generally given credit for. I got a little gangway here. I had to reorganize the Lego train here to have a proper walkway. And I kind of did that, and I want to try to get a door through here, but it's like all the instruments right on the other side of this wall here, so I'm like, okay, well, how do I get a door through there? And so yeah, it's an ongoing project. Well, yeah, because it's a project, and let's take a closer look at it. So yeah, it's got gauges and crap all over the place. It's got the same controller, same little display. Because I'm controlling the train from the yellow train, this button is locked out, and I can't control it from here. But let's continue the test, and let's go back here and release control of the train. Alright, so we're going to release this control. Now with the control released, we're going to go back here. Well, of course I can't get in there. To kind of squeeze in here anyway. So this is now released because I've control here, and turn on the traction, turn on the lights, and yeah, the lights are now on, and see, the lights on the Mad Dog are now on because it's all set to the we don't need the APU because the Mad Dog is providing power. You're gonna let's see, the brakes are off, so we'll just apply throttle and see what happens when we move the train forward. Let's see if we could drive the Mad Dog to slippage, and just give it a crazy amount of power, and away we go. Let's give it more power. I mean, I try to calibrate each of my trains so they hit slippage about the same point on the throttle. So all of the trains should provide good traction between like 1% and 95% throttle. And we're clearly commanding the Mad Dog. The Mad Dog is now slipping, and we're doing that from the controls here. We can go and let's see, the brake actually gives it, and let's apply the train brake. So we'll apply the train brake, entire train, bring it to a stop, and reverse it, and the train works fine in reverse. So here we have throttle controls, and in the Mad Dog we have speed controls, and they both work on the same train. Now, of course, depending on which control station is active, and everything's golden. There's this guy. He likes this thing for some reason. Yeah, I guess. people have been abusing a vehicle cleanup on my map, and like stuff I was working on would just disappear from under me, and it drove me up the wall. All right, let's look at our problem trains here. So this one was created by Lorgs. I don't know whether it's still on Workshop, but the guy. He's basically famous for his VTOLs, but he's an incredibly talented designer, and I put my system in it. Now I got all these holes in the control panel, and most of that is unassigned, and and that still works. That's a nice like it's got a door control. Like I can see the door up there. I can close the door by that, and door goes closed. Cool. So yeah, this is sort of a problem and a thing I've had, and I don't know what to do with that control stand. I'm just not a designer, and I can't really figure out what to do here. Control stand driver standard. I think the train control system is way back here. I completely rebuilt the engine room. Like, he was using discrete tanks all along here. Took all that out, so everything back there is fuel, basically. It's a diesel electric, so it actually it controls the electric motor, and then the generator is controlled by the power system controller. It's got, like, these are the thermostats for the heaters and stuff, and so it's got, and then they get once again the train control system is Train Master Controller. It's older version. I don't care. It's back there and it works. So I guess that's not really a problem. This one's a problem. All right, the 730. I want to stress 1,000 times that Geronimo is an actual conductor, and he did an absolutely brilliant work on that train, and nothing I say here should is anyway a disparagement about what he created there. It's just, I mean, he's a absolutely wonderful player, and an experienced conductor. So there's nothing but respect for that guy. But let's see. Let's see. Yeah, the 730. And now, try not to scream when I press the button here. This is the electronics module. Most of it's discrete logic. There are controllers here. He does use purple wires here and there for a number of different things. But this is what he gave us. And I mean, there are other problems on this train which I will absolutely not criticize him for. He's got discrete and the fuel tanks down there. No criticisms. It's just it is what it is, and just nothing to. Yeah, I called it a basket case because that's kind of what it was. Now, what I've been doing here is I've been OCDing it, and by virtue of OCD, you can see holes all over the place in the controllers where I've managed to combine stuff or remove stuff and optimize stuff. So it's almost under control here. Now what's emerged is, let's see if I can find it here, is this controller here. The WH air brake control and HOTD. I mean, it's sort of a train brake in a way, and he's got the brake stand cut out, the brake pipe, and so he's doing it. It's kind of fledgling. Again, no criticisms. It is what it is. But I'm looking at this now. This is an attempt to model real brakes, and this is again one of the trains which tries to model a real locomotive here. And I'm looking at it, and this is a train where my stuff is optimized for for video game play. So I got a video game kind of controller, which works very, very smoothly, very, very well for what it does, but it does not handle this case where you're trying to simulate a very advanced control here. So the question is, how would I integrate my controls with this? Or maybe I just say, okay, well, this is a different type of system. I'm not going to integrate my controls into it. So so what do I do? So I'm basically, the EOS guys came up with this Wabi sim, and when I took let's find my key here. Not that. Yeah, this. I mean, again, I've been OCDing this once again, and I've been. I mean, you sort of know what I mean. Like this is a very complex system that tries to model a lot of things that Geronimo did with his train, but he does it in this controller. And there's a lot, Geronimo does have an end of train device, and this system also has an end of train device. So they both have end of train devices. That was what I'm saying. But here, and they're trying to penetrate this. I mean, even after OCDing this for hours and hours of OCD here, I'm barely beginning to penetrate it. I think what they're doing is that they have these. They're using these PID controllers as integrators. This is what's called where they take the process variable and feed it back into the input variable. I think that behaves like a memory cell. So they're getting like an invisible, sort of an implied memory that it only processes this function once per tick. So when it comes back the next tick, it has the previous tick as the input. So it's basically a delay line or a memory cell. And it's behaving kind of like an integrator. I'd actually have to simulate this and figure out what the heck and actually graph out what this thing does to even begin to understand this controller. And I look at parts of it and okay, I'm like, this makes sense, or this doesn't make. But I think it is basically trying to do a train brake, where each car has a cylinder, a triple valve, and a pressure reservoir, a triple valve, and a cylinder which operates the brakes on the car. And I think the locomotives have one brake per axle, or one cylinder per axle, where the rolling stock might have a single cylinder, and then it uses a set of bars and levers to apply the brakes to all the wheels, or all four axles, or whatever it has on it. And I think that's what it's trying to simulate, and it has to, okay, well, how many brake reservoirs does it have? Well, it has one reservoir per car, and it has to go, and it has to compute that, then it has to look at how many cars it has, so how long does it take, how much flow rate can it, and when it tries to simulate sending air down the pipe. So it does all these things, and it looks pretty impressive, and I have to call it awesome. But then once again, looking at this thing, and then going back to Geronimo's train, okay, well, I want to put this into Geronimo's train, and then I have to figure out how to do this correctly, or if I want to make it somewhat compatible with my systems, or the two systems play nicely together, or the systems, or at least like if I have a Wabi Sim car and my system, make sure that it doesn't then crash and burn. So, I mean, it's going to be a long road. I mean, it's promising. Once again, this is called Wabi Sim, and it's one of the engineers of Stormworks standards, and I want to call it good, and I'm just gonna go ahead and call this good, and just for the sake of being even-handed. I mean, it's got a pretty good tutorial section here. I mean, there's a lot of OCDing to do on the controllers that I'd probably want to use my post OCD controllers, just because they're tighter and more efficient and less objectionable than the original. I mean, another problem locomotive is the blue one, the one that's still that I was using to construct the train. This designer, I mean, I already talked about the problem with the skirts earlier. And how the joints were doing numbers with me. I think I'll just have to weld the entire thing and get rid of those pivots, because they're just simply not working. And so I'll get on here. So it was really difficult to get this running. I took out one of the circuit breakers, and I had to, just because I organized things differently, and I know the controllers, there's a whole pile of controllers stacked up in here, and a lot of those had to do with how the engine used to be. Now that I've reorganized the engine, it's going to be a little different, so I have to go through this and figure out how I want to change it. I mean, but the design here, let's just take a step back and just look at this interior. This is brilliant work. Absolutely mind-blowing brilliance here. I tried to get in touch with the creator, and he's not talking to me. And I don't know what's going on with him. He's not talking to me, so there's nothing I can do on that front. So I'm looking at this. Well, I mean, and again, he's got another, and I don't know whether I can pull his. I'll pull another one up in the workbench so we can look at it. And let's just hop back over here. Let's see. Let's see. Yeah, these are once again the controllers that I mentioned here. The engine panel, the engine data. He has a dead man switch system. I think I had to disable it because I ripped parts of it out just because I didn't. I needed it out of my way so I could test the train properly. See, he's got the controller for the engine. Again, more engine data. Let's take a look at this. What's in here? So it's basically nothing. It's basically collecting a lot of stuff from the engines. And okay, that's fine. And here he has a railway air brake controller, and again, I mean, it's basically another version of Wabi Sim. So once again, you find these integrators with the lines, the input fed back to the output. It's not. I mean, I guess Wabi Sim is sort of built on this. I mean, I want to like Wabi Sim, but you saw how messy it was. I mean, like, this train already has an advanced brake simulator on it, so therefore, if I'm going to refit it, I'm not just going to rip that out and put my stupid system in there. I want to maintain it as an advanced controller, but it's just. So I mean, like, let's say I want to drop Wabi Sim in here, and again, I mean, I got a lot of integration work to do. I've got to and I make sure I mean, this is brilliant. This is gorgeous. Well, I mean, I had to slip in an additional digit because I was getting this thing up to 170 miles an hour. He's got this sign panel here, max speed 85. No, this thing goes 170, and so I had to put another digit on the speedometer. And well, yeah, I mean, it's just I have deep respect for this design and how elegant and how artfully it's laid out. But I mean, and I forget I think that was part of the Dead Man system that I ripped out of there so I could get the train rolling. So I want to put this back together and make it and just make it as true to the original intent as possible. But it's just take a huge amount of talent to get this the way it should be. And I have a lot of respect for this design. So yeah. Well, let's pull up the last train now. Yeah, there it is. Yeah, what's holding me up on this train is, I mean, I have the engines are just about where I want them. I mean, it's good. I probably can get rid of this battery because I don't need it anymore. But the problem with this train is this controller here. It's got, I mean, I've sort of, parts of it are disabled. I've been trimming it down quite a bit, but it's still got all of these. I mean, it's still handling the brakes, and it's got this here. Let's take a step back and look what it's connected to. So it's driving the lights through all of it from that single pin. And okay, if I want to drop in a new controller there, I'm gonna have to carefully figure out where all of this crap's mapped out to. And I don't think there's much left inside the controller, but it's still. Yeah, it's let's see, where is it getting it? Data input to. Yeah, I think it's another very primitive master-slave system, and it's most of it I've ripped out, like the diesel throttles out. Yeah, so you see it's another one of these systems. It's got a diesel throttle and electric throttle, just like EOS. And again, it's got to go. It's crap. But so that's what's holding me up on this train, and it's just. Let's take a look at what the lighting is. So he's got these. Since he couldn't get two lights up here cleanly, he sort of turned it into a paintable sign. I think this train was built before spotlights were in the game, so he just has basic lamps here, so it doesn't really project much light. I mean, I like it and I want to honor this design. It's just that this. I mean, with all these targets here, it's just a little bit much. Then after that's sorted out, I have to go back into the cabin, which I've already shown you. But the cabin is still the way it was, and I have to figure out how I want to work this console, and I get this set up decently, and that's I mean, the engine controls are kind of nice. It probably needs a... I just don't know. I'm just sort of... I don't know. Anyway, that's basically what I've been doing in Stormworks, and those are sort of the problems that I've been... Or the... Sort of sharing what I've been working on myself, or things... trains in my... I did an inventory of how many trains are in my collection. I have about 55 different locomotives in my collection. All of them but I have my favorites, and these are among my favorites, and I want them as good as they deserve to be. And so basically, even though I'm just maintaining them, and probably out of respect for the original authors, will never republish them, I still want them in really good condition for my own use and for use in my own trains. Like you can see, and one of the things I do is I put these on. Oh, that's kind of jammed there, but yeah, it's got got these so I can just hop between trains, and that's nice to have too. Anyway, that's it for this video. Thank you so much for watching, and I hope that I may have learned something, or may have, I don't know what you could have gotten from this video. Maybe you just wanted to waste however many hours, let's see, an hour and a half on what I'm doing with trains in this game. But anyway, thank you very much.